Hey, I'm here today to talk about a blog post I wrote. Why is everyone in Ethereum talking about TEs? And that is my name, Jason Jaskin. Who am I? I've been working at the Ethereum Foundation for a little over a year now. And I like to joke that I work at my role is within the Ethereum Intelligence Agency. I try to make sure that everyone at the EF is up to date on the latest that's happening in the ecosystem across all layers, whether it's infrastructure, governance, apps, and I put together like blog posts, research reports, shorter posts, just making sure everyone's up to date, and also outside the EF as well in the broader ecosystem. That's actually how I came in contact with Rajiv here because I wrote a post about TEEs about a month ago because I saw that they were being deeply integrated into Ethereum infrastructure across L2s, mostly also in the block building side. I know that Flashbots has been talking about them for a while. And like I mentioned earlier, I try to write about all different aspects of the Ethereum stack. And you can see on the left is kind of my blog where I've written about multiple things. However, one of my latest posts, this one about TEs, I was asked to come talk about it because I tried to cover as many things going on in the Ethereum ecosystem that are using TEs. And so hopefully this will give you a good high level intro to them. I wanted to say a quick note. I'm certainly not an expert in either TEs or where they're being used across the ecosystem. I did talk to a lot of people and I did or read a bunch of kind of docs and watched podcasts, but I am not an expert. I would recommend to reaching out to the actual people building the software if you do have questions about the specific products. All right, let's start about how do we get here with regards to seeing TEs used in Ethereum. It really starts with Flashbots. And that was back in 2017. Phil Diane, who ended up starting the company, wrote a blog post, which he took off the internet, unfortunately, at least I couldn't find it, called The Cost of Decentralization in 0x and Ether Delta. And this was during the ICO craze. And he saw that there would be a way for people to kind of take advantage of ordering of transactions in order to profit. And previously, people had only really known about, or not known about, it was only thought that you could kind of maximally take profit as a validator just by listing them in order of the fees. And now Phil kind of discovered this way of like what we now know as MEV and now is like very popular across the Ethereum ecosystem. And he first realized that in 2017. And then in 2019, he wrote his very famous paper along with other people that you can see listed there called Flash Boys 2.0, where it really articulated how this would be possible. And they actually built bots that are taking advantage of DEX trades. And fun fact there, he actually, when Hayden Adams originally proposed Uniswap and made an ETH research post about it, he immediately messaged Hayden and Vitalik and said, this is a terrible idea. People are just going to exploit this for profit. And that is ended up what happening. But Vitalik kind of said that that'll be a built-in cost and we'll all figure it out. And that is also what ended up happening. So it's kind of funny they were both right there. And yeah, so then in order to kind of prevent these negative externalities of MEV, which would be, so say that I'm a validator and I'm supposed to be just originally was thought of as a node that just lists transaction or sorry, lists. Yeah, when you make a block, you would list the transaction by their fees. However, if you're a sophisticated validator and you're really good at extracting MEV and you have a lot of compute, and then you're doing a bunch of sandwich attacks and other attacks where you're able to make more profits than a validator that's just going to list them by transaction fees, then over time and because of economies of scale, you would grow bigger and bigger. And the validators that are only able to list blocks by their transaction fees would get smaller and smaller. And this would really centralize the network around these validators that are just able to extract as much MEV as possible. So in order to prevent this, the validator set from becoming centralized, Flashbots built this software called MEVGet. And this was back in the proof of work days. And this allowed block builders, or this allowed miners to actually reach out to an external network. And these external network of builders, they can be high sophisticated and they'll be competing in order to build the most valuable blocks. But at least the miners, they could stay low software. And then in the next year, with MEV Boost, this was after the merge, and it was similar software, but now for validators. And we can keep the validators low compute and make sure they stay decentralized, but export the actual building of the blocks to block builders. And that's what we saw. This is a picture I took from MEV Boost, MEVBoost.pix is the website. And we have a network of 28 builders in the last 14 days. And actually 91% of blocks are built using MEV Boost. So validators are using this service in order to get more profit out of their blocks. And we're seeing 28 builders. So problem solved, right? Unfortunately, no. This builder market has not been decentralized. There's been two main builders and one third kind of builder that I'm shocked to even see the numbers are that high. But previously, the third builder's numbers have been really low. It's really a duopoly. And this is causes a lot of problems to the network. If we're relying on two entities to build blocks and say one of them goes down, or maybe both of them goes down, we obviously have a huge liveness risk to the network there. And also censorship resistant risk. If there's a situation where the government maybe puts an entity on a certain list like OFAC, and there's only two organizations that they need to go after in order to make sure they comply, it's very easy to introduce censorship to the network. And so this is a problem that that Flashbots has been working on, kind of trying to solve. Once they solved the problem of making sure that the validator set on Ethereum stay decentralized. But now the next problem is we created this external market of builders to build blocks. And the problem that they're now trying to solve is how can we decentralize this market? So here's a picture of Phil Diane, and he's thinking how to try to solve this problem of builder decentralization. And these builders, they're working in very high compute, high latency environments because they want to build these profitable blocks. And in order to solve this, we need actually privacy in high latency, high compute environments, because the way that we're seeing these blocks be built is people are only like selectively revealing certain elements of their transaction in order to allow certain elements of MEV, but not others. So say, for example, I would say that I want to swap ETH for USD, and I actually talk about this later in more detail, but I don't want to give the exact amounts and my like slippage percentage, so I can't be front run, but you still allow the builder to back run you. So in order to solve this problem, we need some sort of solution that allows you to get privacy in high latency, high compute environments. So when you hear privacy, at least me, I initially first think of ZK, but unfortunately ZK is not going to be a perfect solution for this because it's too slow and it's not like adaptable for specific solutions. It's only like very, like you have to have the certain inputs and certain outputs, and it's just not adaptable enough. So too slow, and it's just not going to work. And that's where they really started exploring TEs. This is back in November 22. Flashbots wrote this post, the future of MEV is Suave. And here they kind of outlined a design using TEs that would allow this, like, at the time, they thought it would be like an encrypted mempool, and it kind of is. And they weren't sure on the exact outputs yet, but they knew that the future of MEV would involve TEs and networks of nodes running TEs. And this was an old design they had called Suave, but it was kind of the first iteration there of what would end up being BuilderNet that I'm going to talk about later. If you're not already familiar with TEs, I think the best way to really understand their value in the world is to think about kind of the evolution of computing. And here, if you start with early computers, which is the top thing in this diagram, when you had an early computer and you would download any sort of software, you kind of just had to trust that that software wasn't going to overload any file systems or crash your computers. There was no ways to kind of check on it. And then in the later stage of computing, now you had an operating system, and that operating system at least allowed programs to be separate and like would stop and start each other. And you kind of had to trust that this operating system wouldn't crash your computer, but at least you had an operating system to keep things a bit more stable. Then enter virtual machines. And now many users could share one computer at the same time, like we've seen now for decades in servers and data centers. And we had to now trust cloud companies to make sure that our data was safe. And we have to trust that these companies are not going to look at or misuse the data that we're like sending to the server there. And there's nothing really to prevent them from doing this. It's just based on trust. And then enter TEs. TEs, I think, once we kind of have this context, you better understand that their value in the world is like, once we have these data farms and you're deploying your application there and you want to make sure that other programs aren't interfering with it, and also just the company that runs the data farm isn't interfering with it. You could think of these TEs as like a secure box, and you know that they're running securely because they actually can prove it. They send out what's called these remote attestations, where you can ask the company that manufactured them to kind of ensure that they're not tampered with and they are running the programs that were actually deployed to them. There's many different types of TEs. I think the one that we probably use every day, if you have some sort of phone that either uses Touch ID or Face ID, that actually uses a secure enclave that's specifically made for just a small cryptographic function like signing like with your face or finger. Then Intel built also SGX, which has been very popular. I think it's probably the most popular TE. However, there's one, and I think that little diagram there is a little nice. If you've never seen TEs before, you can see that there's like different parts of the memory, and if you're in like the enclave where the data is actually encrypted, you know that it's safe as long as the TE is sending the remote attestation saying that it is okay. And but one thing about the Intel SGX is you really had to like modify your program to fit it. And it was just for like specific programs that you would put inside the SGX, and you have to make sure that with regards to modifying the program, I mean that it would there are certain like functions that you would have to call in certain libraries that you would have to use, and you can't really just copy and paste your code over. And it's also slower than using just a normal computer that isn't running that doesn't have a TE in it. And then Intel actually introduced TDX, I think late 2023, early 2024. And that actually allows you to kind of just copy and paste your program, and you can run entire virtual machines inside Intel TEX. And you can do that at the similar speeds as you would on like a regular machine. But there are risks with TEs. With TEs, you are trusting the manufacturer. I think this tweet from Dankrad, who's an EF researcher working on cryptography and consensus, really drives that point home. He says, many people I talk to seem genuinely surprised that using a TE means just trusting the hardware manufacturer. And yes, that's true. The software within the TE is closed source. There are efforts to build open source TEs and to reduce the trust assumption, but it's worth noting that you are just kind of trusting the manufacturer that they built the hardware like they said they would. And I think it's important to think about trust models with anything that we're doing in the Ethereum space. Vitalik has a really good post called Trust Models that I put the link to on the screen. And you can think of it like, is it one-of-one trust? Is there one person you need to trust to be acting honestly? In this case, yes, you would need to trust the hardware manufacturer to be acting honestly. Is it something like a blockchain where you just need over half of the people to be trustworthy? Or is it just one or two people of multiple you need to be trustworthy in something like a trusted setup or fraud proof? And so it's worth keeping in mind that this system is a one-of-one trust, and there are certain risks with it. One of those risks is side channel attacks, which is we've had a couple kind of unfortunate real life examples of this with Meltdown and Spectre. I recommend reading about these because it's super interesting if this is like a path that you're interested in. But all because that the TE is doing operations in a secure enclave. These computers and servers are still doing certain functions in order to like speed up the processes. So whether it's out of order execution or using the cache, obviously, and there are certain attackers that are maybe kind of taking advantage of this fact, and they're able to kind of extract the private key that lives inside the TE by doing these crazy side channel attacks that once again I would recommend looking into if you're interested in this. There's also supply chain attack. So once the chip is actually made, you have to make sure that it gets into the computer and is safe and sound, and that whole process, there's nobody tampering with it. And there's so many things that can go wrong in that process. And so you have to make sure that the supply chain is safe. But one thing I want to kind of let you guys know is it's not just the Ethereum space that's really looking into secure hardware. On the left, you can see OpenAI made a blog post that they're looking into secure hardware for their like AI processes. And on the right, Apple is also looking into progressing secure hardware for their AI privacy as well. And the Flashbot team is doing really amazing work on this. They understand, I think it's kind of similar to the way that we look at blockchains, where we understand that there's certain trust assumption, and we want to make sure that users are as safe as possible. And there are things that you can do in order to make it more secure. And that's kind of what these blockchain researchers are doing. Flashbots has also started doing similar work where they wrote a blog post on the left, kind of outlining the problem and how they want to kind of make this all more secure than it currently is. And then on the right, they focus specifically on supply chains and how that we can decrease trust in the supply chains. And if you're interested in contributing to this research, they are looking for contributors and they're looking for security experts. So please reach out to the Flashbots team. I know they'd love your help. Yeah, so like I mentioned earlier, or sorry, I didn't mention this earlier, but Flashbots first used the Intel FCX to build a block because they used to run a block builder, and they actually built a block inside the Intel XGX, the TE. This happened on March 2023. However, because it's at least 2x slower, it wasn't competitive in the block building process. So it was like a fun proof of concept, but they knew that this block builder kind of wouldn't actually be competitive and compete against other block builders that were using like hardware that didn't have this TE functionality in it. However, once Intel introduced their TDX, they first built a block inside of it. This is Flashbots again in May 24. You can see on the left, that's the blog post when they first built it. And then they were also searching inside of TDX in September 24. So they were, and like I said earlier, TDX allows them to kind of get the same benefits of private secure encryption. But however, it is just as fast as using a computer that doesn't have those features. Yeah, so here I wanted to outline the benefits of TEs that are in block building and in this block building supply chain. This is actually the same example that I talked about earlier, but I'll just say it again because I think it's important to kind of hammer the point home. It allows you to say that you're going to make a transaction, but not reveal specific details about it. So in my transaction, I would say I want to swap USDC for ETH, but I would not say the amounts I want for either. And I wouldn't say my identity as well, because there's ways you can take advantage of that to get MEV. Just I want to swap A for B. Using this, you're not allowed, then you can't do like a sandwiching transaction, which like greatly hurts the user's ability to get the best price on their swap. But you can actually still like verifiably construct the block in your the algorithm that you have in the TE and still get back running arbitrage. So you're still able to profit from this transaction, but you're actually not hurting the user, because it doesn't hurt the user if like if I swap USDC for ETH, but then there's now a pool imbalance on another pool. And a searcher comes in or a block builder comes in and fills that arbitrage, that actually makes the market more efficient and the builder profits. However, that's actually not hurting the user that makes the swap. So the TE can allow you to like create an algorithm where you can still get back running arbitrage, but not hurt the user and take advantage of them and front run them. So now I want to introduce you to BuilderNet. BuilderNet went live in November of last year, and it is kind of the final development or child of what they imagined Swap would be back in November 22. And it launched with Beaver Build, Flashbots, and Nethermind. And Beaver is a very significant player to be involved in this, and I'm going to touch on their involvement next. But first, let's just talk about what BuilderNet is. So what BuilderNet is it was explained once, and I think this was a really good way for me to wrap my head around it, but it's infrastructure that allows you to kind of access all block building capacity, and then the people running the infrastructure can then just focus on searching. So previously you had to potentially do both like the searching and block building features together if you wanted to like maximally profit. Now you can kind of tap into this BuilderNet infrastructure, and you can just focus on like searching and building blocks and not necessarily running the infrastructure that comes with building blocks. So to be more specific, if you want to be in this network of BuilderNet, what you have to do is you have to run the BuilderNet software that Flashbots built, and that software you have to run inside a TE. And they're actually all running the same software. So it's building, all three of the people or however many nodes that are in it are building the blocks together, and you're all running the same kind of way to construct the block at the end to come up with the final transactions. However, you can kind of customize it in your own way eventually. Right now, I think they're actually all running the exact same software, but eventually you'll be able to run like your specific searching algorithms in order to best like construct the block to benefit to benefit yourself. But right now, you're all running in TEs in order to like keep that privacy that I mentioned earlier, and to prevent you from front-running users like we talked about earlier. And one thing that's cool about BuilderNet is that there's actually fair MEV redistribution. So previously, or the way it works now, is someone like Beaver, who's one of the biggest builders, would go to, say, a Telegram bot or somebody like MetaMask, if they have like a private RPC, and say, like, look, I want access to your order flow. If I get access to your order flow, I'll pay your users back X% of the MEV that I generate. And they have to go and they have to source all these deals. And it's also very opaque in how they're actually returning the MEV, because there's no like discrete algorithm that they know that they're running that's open source. They kind of just have to trust, based on the amount that they pay in order to get their block included, that that value is going to be returned to the users. Um, but and so this requires a lot of work for builders. They have to go and they have to talk to these wallets. They have to come up with these deals. Everything's opaque and it's just a bit of a mess. But with BuilderNet, because everyone is running the same software and the software is open source, and you know that that it's going to do what it says, because of that, it's actually able to return the MEV to the users. And it does this automatically, and it would be maximally beneficial for the users to like send your order flow to BuilderNet. And then because of this, because you're sending it like to BuilderNet and the order flow is like selectively shares certain things about that, you can share it between all the operators and know that you're not like revealing anything that is that's like proprietary to you. So TLDR, it's kind of a way to attempt to decentralize the builder set, because anybody can plug into this network of builders and you could share order flow together and you can kind of get access to this building infrastructure. But one thing that is like the immediate question that you might be having, and it's a very good one, is Beaver, which I talked about earlier. Actually, when I showed the percentage of all the top 3 builders of blocks, Beaver is number 1. They build 45%, I believe, on that chart that I showed. So why would they choose to join BuilderNet? They already did all the work of sourcing all this order flow. They're already one of the best builders, where they're getting they're building all these blocks and they're being able to profit from the MEV they generate. Why would they want to join? So at least this is what this is what's been asked to Flashbots who built the software, and this is what they said was the reason why BuilderNet joined. Beaver Build joined. I'm obviously not Beaver, and so I can't go inside of their head and know the exact reasons. But what they said was they actually want to, or what Flashbot said on their behalf was they started as a searcher. Searching is their strength. Searching means like when you're actually the ones that are building these bundles, and you're the one that's kind of doing the work of generating the MEV from like specific transactions that you see, rather than making the final block. And there's a lot of baggage that comes with being a builder. When you're a builder, you have to source all of these order flow deals, like I mentioned earlier, go to wallets and go to Telegram bots and negotiate on how to refund certain amounts back to the users. And then you have kind of a spotlight on you, where if something goes wrong with the block building in the end, people are ringing your name and they're tagging you on Twitter, and it's a bunch of pain that you might not want to deal with. And if they join BuilderNet, then they can solely focus on searching, which is their strength. They also claim, which, I mean, who knows if this is true, but they want to have long-term Ethereum alignment, and they want to kind of, in order for their business to be maximally profitable long-term, Ethereum like can't be corrupted long-term, and Ethereum needs to like be its most successful long-term. And so if there's only a duopoly of builders, this like hurts Ethereum's kind of position in the world as like a neutral protocol. And so if they join this kind of network of decentralized builders, then it will help Ethereum be maximally long-term beneficial in the world, which might hurt their business in the short term, but would help their business in the long term. Okay, I said Beaver joined, but did they actually really join? Well, kind of. If you look at this chart on the right, you could see this was from blocks built yesterday, actually, that I got from a Dune dashboard that you can check out if you go to that link below. Is Beaver still built the most blocks by far, not using BuilderNet. They're only using BuilderNet for a very small amount of their order flow. So you can see on the bottom there, you can see Beaver built 35 blocks using BuilderNet, and then you can see the other 2 teams as well that are operating that as well. Nethermind and Flashbots, they built 28 and 22 respectively. But Beaver is still running their normal builder that is not using BuilderNet, and that's still where a majority of their order flow is going. And I asked Shay from Flashbots about this. She's like leading the effort, leading the I guess the product team at BuilderNet. And if you have any questions about BuilderNet, I would recommend reaching out to her. And what she said is they're working really closely with Beaver to benchmark performance and to run tests to ensure a smooth transition. And she expects more order flow to shift over in Q1 of this year. And we'll see about that as we're over halfway through Q1 and they haven't really moved much order flow. But I understand like building this whole bootstrapping a whole decentralized network in something like Intel TDX is still really new, and they want to make sure there's no bugs. And at least Flashbots is confident that Beaver will move more of their order flow and kind of eventually maybe even shut down their centralized builder the same way that Flashbots did. Whether they will or not remains to be seen. And so right now they're operating this network with the 3 operators that I mentioned earlier. And in the roadmap, they actually want it to be a permissionless set where if you're you actually want to contribute to building blocks and you just want to focus on like the searching aspect as well, and you don't want to deal with the whole block building thing, and you don't want to deal with sourcing order flow, you could just tap into BuilderNet and you could just become a permissionless operator. So that's on the roadmap, and they have other things as well, as you can see below. Flashbots has a blog post about this. I would recommend checking out their blog post to read into their roadmap for more details. Next, I want to talk about Rollup Boost, which is another software that Flashbots built using TEs that has started to get some traction in the Ethereum ecosystem. And the reason why was, so they've been looking into TEs now for a couple of years, specifically for the purposes of decentralizing the builder network. But then they realized, wait, these TEs are extremely powerful. And especially with Intel TDX, you can do some really powerful things with them beyond just in the MEV pipeline. And so that got them thinking. And one problem that they came across in the L2 kind of vision, which I definitely agree with them, has not been ideal, was L2s are kind of just forking get, and they're following L1 upgrades. They're not innovating on the virtual machine themselves. They're just relying on the L1 to do so. And the L1 has kind of other priorities as well, because the L1 is now not just an execution layer, it's also a settlement layer for L2. So it's focused on kind of being a robust settlement layer as well. And so they're not spending their entirety of time focused on kind of upgrading the virtual machine anymore. Meanwhile, one thing we were hoping when we introduced the rollup-centric roadmap was that L2s would also innovate on their virtual machine as well. And if anything, it can happen the other way around, where L2s could actually do new innovations like parallel transactions. And then if it all goes well, the L1 can actually bring that in. However, we've seen almost no innovation with regards to virtual machines. The L2 teams are simply forking get, and they're following L1 upgrades. So that led them to create an additional sidecar. In a similar way, they built MEV Boost as a sidecar for validators. Well, they built this new sidecar called Rollup Boost for sequencers. What this allows the sequencer to do if they run this sidecar is enable what they call extensions that allow for kind of additional features to their VM that you wouldn't be able to do, or sorry, you, instead of just having to like completely rewrite the source code from scratch, and if you wanted to access things like faster block times or verifiable ordering, which is the first 2 extensions that they announced, you would have to completely rewrite the client. Now you can just run this sidecar, choose the extensions you want to run, and you have access to those features. And this sidecar is built in a TE in order to ensure that it actually is running the extensions that it says that it claims to be running. Now, the first rollup to actually take advantage of these extensions was Unichain, which went live, I believe, last month. And it is using 2 extensions, one called Flash Blocks, which allow for 250 millisecond confirmation times, and native revert protection, which I think is really cool, where if you're going to do a swap and the swap will actually fail in the mempool, it will revert and you won't be charged for it, which like kind of makes sense. Like imagine we're used to this in the real world, paying for reverts. Sorry, and like if you've been active on chain and Ethereum for the past couple years or however long, you're used to this. But imagine new users if they're just used to worlds where like you enter in the incorrect password, you're not charged for it. And so this allows for native revert protection. And also, you're actually increasing the gas throughput by doing something like this, because the way that blocks works is they're kind of streaming blocks in a similar way that a network like Solana like streams out their blocks. And because you're streaming out blocks, you're able to like better fill up the like gas limit within that amount of time. And then once it comes to full blocks like that, the units at like an OP stack chain has, where I think are like 2 seconds, I believe, you're actually able to better include more gas into that entire time, because you're like filling up everything within that 250 milliseconds. And so yeah, so users are able to get fast confirmations, and you're able to increase gas throughput. And then another thing that they're doing is verifiable priority ordering, which means you actually are ordering the transactions in the block by the fee that the users want to pay. And this allows applications to better internalize their MEV. We also recently saw Base. This actually happened after I published my blog post. They also chose to integrate Rollup Boost specifically for the Flash Blocks extension. And they are using this extension to bring their blocks down to 200 milliseconds rather than the 250 milliseconds. And that's already live on testnet, and they say it's coming to mainnet in Q2. The Flashbots team also has a roadmap for Rollup Boost. They also have a blog post where they go into more detail on all of these, but the Rollup really emphasizes new extensions that they could use. This involves having an encrypted mempool, key co-processing, parallel execution. And so if you want to learn more about Rollup Boost, I would recommend reading the blog post they put out about this, or reaching out to Robert Miller and Flashbots team. So another area where we're seeing TEs be used in Ethereum is for multi-proof systems on L2s. Now, this also didn't come out of nowhere. Around the same time that Flashbots wrote the Suave post, where they had the idea of integrating TEs to kind of make the builder market more decentralized, Justin Drake was inspired by that, and he was talking to the Flashbots team, and he made a post on ETH Research his idea was doing a 2FA ZK rollup, where currently, if you want to progress the state of a ZK rollup, like the bridge that lives on Ethereum, the way it's secured is via a snark proof, a ZK proof that you have to use like in the smart contract in order to prevent the state. And that's how you know that there's that state root that's being applied is in fact the correct state root. However, ZK snarking the EVM is extremely difficult, and developers and researchers have been working on this for years, and it's progressing way faster than anyone could have imagined. However, we are at risk of there being a bug in the ZK prover itself, and that would be catastrophic, because if there's a bug and we advance an incorrect state and a hacker is able to take funds from the bridge that are not theirs, then the bridge becomes insolvent, and that is just a disaster for the L2. So Justin came up with this idea to actually create a 2FA on the bridge proof, where that proof would actually be an SGX TE proof. And so you would include both proofs, and then if the two don't match, then you were able to actually come in with the Security Council and resolve that problem. So you're able to provide a backup in case there's a bug in the snark proof. And so this was an idea Justin had in December 22, and we saw it come to life kind of recently, as Scroll has been kind of trying to implement this idea, and they're working with Atoma in developing an open source SGXT ZK EVM prover, and they've already used this to validate blocks on testnet, and they want to go to mainnet as soon as possible. And what they eventually want to do actually is provide even more diversity within the TE prover, and not just use Intel SGX, but also use AMD and AWS as well, as you can see below. And then that will be a 2 of 3 TE proof with the ZK EVM proof. And then if those two disagree, the Security Council will come in. And so this allows for the rollup to be much more secure. Also, Tyco is using TE proofs. However, their design is very interesting because they're a base rollup and they are submitting blocks every 12 seconds. They needed something that would be really fast, and ZK proving state transitions are not fast enough, like I mentioned previously, in order to do something like proving a ZK EVM in this speed, or really any type of operation like this. So they actually integrate TE proofs to provide initially fast confirmation for their users. And then the ZK proofs can go back and challenge TE proofs. So they kind of have this design where they're somewhat of an optimistic rollup. Then the ZKPs can provide additional security and check on the TE proofs. But by running it in a TE, they're able to kind of give the users more assurance than running it without a TE. And so that's an interesting design that Tyco is currently using. And they also want to eventually pivot to multi-proofs. But for now, they're using these TEs as this initial fast confirmation. And so that's it. Yeah. Thank you all for listening. And if you have any questions, I can be reached on Twitter at jchaskin22, or you can ping me on Telegram at jchaskin. And again, I can try my best to answer, but I'm certainly not an expert on any of these subjects. I would recommend reaching out to the Flashbots team, the Scroll team, Atoma, or Tyco if you have specific questions about their implementation. And so, yeah, thank you for the time. I really appreciate it.